This week, we're going back to basics, like really back to basics, on the Data Radio Show. Hello there, and welcome to this week's episode of the Data Radio Show. Over the last couple of weeks, I've been getting a number of messages from people saying that they wanted us to do something a little bit more back to basics, a really wide introduction to the field of data management for people, because while it's easy enough to make content talking about things like data architecture or the principles of privacy, sometimes people looking to get into the industry or upskilling or changing their career path might not necessarily have that knowledge base in place of some of the basics that other people in the industry take for granted. So, this week we're going to do a bit of an AI deep dive into data architecture itself, what it is, how it works, what the elements are behind it, so that people who might be considering a move into the industry or to learn more have got a bit of a resource there for that. Before we jump into that interview though, which is, as I said, all AI, I wanted to have a chat to you about April the 3rd in Melbourne. We've actually got a community meetup going on where we're going to be talking about things like asset management and data management. It's a bit of a mix of things. The idea is to showcase the best practice approaches to moving up the data maturity curve, as well as focusing on how data quality can help improve better data products and better outcomes for people. So you might come across a few ads in that running at the moment around the place, but if you're interested in going, I'll make sure that that link is down in the description so that you can just RSVP onto that directly. It's April the 3rd in Melbourne, Australia, and we've got the team from Scale Free from Germany over there doing some presentations. It'll be a really fascinating experience for everyone. Right, let's jump over into this deep dive. It's about half an hour long, and let's learn a little bit more about data architecture.
All right, hey everyone, welcome in. Today we are going to take a deep dive into something that's honestly kind of foundational to how we use data in, well, just about everything these days. Data architecture. You know, it's interesting because you don't often hear about data architecture out in the wild.
Right. It's definitely more of a behind-the-scenes concept.
But it really is super important. If you think about it, it's like the blueprint for how any organization that relies on data, and these days, who doesn't,
Yeah.
actually manages and uses that data effectively. Like, you wouldn't just start building a house without a detailed architectural plan.
No, definitely not. You need to know where everything goes, how it connects, and what materials to use. Same idea applies to data.
Exactly. So to really get a handle on data architecture, we've pulled in a whole bunch of resources that we're going to dissect today. We've got some great YouTube videos, one from Dataiku called Crash Course in Data Architecture, and another from SAP titled What is Data Architecture? And then we've also got some really insightful articles, one from AWS that lays things out really well, then another from Dataversity, and one from Atlan too.
And it's cool because each of these sources kind of brings its own unique perspective.
Totally. So our goal today is to pull out all the key insights, like what are the core components of a data architecture, what are the different types of architectures, and what makes this whole thing so darn important. Whether you're about to walk into a meeting where everyone's throwing around data architecture terms or just curious about what goes on behind the scenes, we want to give you that solid foundation.
And I think it's important to highlight that understanding data architecture isn't just for super techie folks.
No, not at all. It impacts us all.
It gives you a way to think about all the data that's constantly swirling around us. You know, where it's being stored, hopefully securely, how it's being analyzed, and how that's all used to make decisions that shape, well, pretty much everything.
So to kick things off, let's get right to the heart of it. What is data architecture?
Okay, so in the simplest terms, data architecture is the overarching framework that an organization uses for collecting, managing, and using its data.
Right. It's the grand scheme of how everything data related is supposed to work.
And what's interesting is how different sources emphasize different aspects of this. AWS, for instance, really stresses how a good data architecture makes data accessible and usable while also ensuring its security and quality.
Which, I mean, that's huge, right? Data isn't very valuable if you can't actually access it, use it, and trust that it's accurate.
Absolutely. And then SAP, in their video, they kind of nail it when they describe data architecture as the technical backbone that makes a data strategy a reality. You can have the most brilliant plan for how you want to leverage data, but without a solid data architecture to back it up, it's just a plan on paper.
Right. It's the difference between thinking about doing something and actually having the infrastructure in place to actually do it. And Dataversity adds another layer to this by pointing out that data architecture is this crucial link between the big picture business strategy, a company's specific data strategy and the actual technical execution of those plans. It's not just about the tech itself, it's about making sure the tech is serving the needs and goals of the business. So while different sources might highlight different things, whether it's accessibility, turning strategy into reality, aligning with business goals, they all point to the same core idea. Data architecture is the intentional design of your data ecosystem. It bridges ambitions with the technical stuff.
Exactly. And as we talk about this framework, it's important to kind of picture the data itself in motion.
Yeah, like where does it live? Where does it go? How does it get from point A to point B?
Exactly. Both SAP and IBM talk about this idea of data flowing through different storage systems like databases and warehouses. It's not just sitting static, it's moving through different parts of the system based on what needs to happen to it, how it needs to be processed, and who needs to access it.
Right, it's a dynamic process. And that flow, IBM highlights this, it's what makes sophisticated data processing possible, things like AI applications. If your data is messy and disorganized, it's way harder, if not impossible, to build intelligent systems on top of it.
It's like trying to build a skyscraper on a foundation of sand.
Exactly. And on a less, sci-fi level, IBM also points out that good data architecture helps us avoid having duplicate data all over the place. It's inefficient, if you have customer information stored in 5 different systems that don't talk to each other, that can lead to errors, inconsistencies, and just a lot of headaches.
Yeah, nobody wants to deal with that.
So a well-designed architecture streamlines things, makes it easier to keep data consistent and accurate. And SAP actually sums up the importance of all this really well. They list out some of the big advantages of a good architecture. Better data accessibility, improved reliability, the ability to scale as your data grows, which is inevitable these days, stronger security, and even greater organizational agility. Basically, it means your organization can adapt more quickly to change.
All because you have that strong foundation in place.
Exactly. So we've got a pretty good grasp on what data architecture is, but what are the core components? What are the building blocks that make up this foundation?
Well, if we look at AWS and Dataversity, we see a few key components that pop up consistently. They're like the essential ingredients. And the first one, which makes sense, is data sources. This is where all the data comes from, and AWS explains that it can be from a surprisingly wide range of places. Think about it. Apps that customers use, sensors embedded in all kinds of devices, internal systems that companies rely on, and even data that's purchased or acquired from external partners.
Yeah, it's a real mix. And AWS makes the point that this data can come in all sorts of formats. There's structured data, like what you'd find in a spreadsheet, all neatly organized in rows and columns. And then there's unstructured data, which is more like text documents, images, audio, video. Plus, it's all streaming in at different speeds and in varying volumes.
It's a data deluge.
Totally. So once you've got all this data coming in from various sources, you need somewhere to put it. That's where databases come in. AWS describes these as purpose-built systems that are designed to handle specific types of data and specific uses. And they break down into 2 main categories: relational databases and non-relational databases.
And the Taiku actually goes into more detail about specific types within each of those categories, which is really helpful for understanding the nuances.
Right. So let's start with relational databases, which Dataiku mentioned are also known as SQL databases. These are like the classic way of organizing data, using that familiar structure of rows and columns like you'd see in a spreadsheet.
In SQL, which stands for Structured Query Language, is the language you use to interact with these databases, to retrieve data, filter it, sort it, all that good stuff.
Exactly. These relational databases, they're really good for handling structured data, the kind of data that fits neatly into that row and column format. Think of things like customer information, financial transactions, product details, anything where you have clearly defined categories of information.
So think about ordering something online. All the details about your order, the items you bought, the quantity, the price, your shipping address, that's typically stored in a relational database. It's structured data that's easy to query and analyze.
Perfect example. Now, on the flip side, we've got non-relational databases, also called NoSQL databases. And Taiku makes the point that these are all about flexibility. They allow you to store data in ways that don't necessarily fit neatly into that rigid row and column structure.
And Dataiku goes on to break down a few of the key types of NoSQL databases, each with its own strengths and use cases.
Right, so there are key value stores, which Dataiku explains are basically like a digital dictionary. You have a key, which is a unique identifier, and a value, which is the piece of information associated with that key.
Think about logging into a website. Your username is the key, and all the data about your account, your password, your profile information, your purchase history, that's the value. This key value structure makes retrieving information super fast because you can just use the key to instantly look up the associated value.
Another type Dataiku mentions is document stores, which are kind of a specialized type of key value store. In this case, the value is an entire document, which could be a text file, an image, or even a JSON object, and those documents can have different structures.
And Dataiku points out that this makes document stores really well suited for handling unstructured or semi-structured data, things like user-generated content, product descriptions, or social media posts, where the information doesn't fit neatly into predefined categories.
Then there are column stores, which, as the Taiku describes, are kind of flipped on their side. Instead of organizing data by rows, they organize it by columns.
And that might sound like a small difference, but Dataiku emphasizes that it makes a big difference when you're running analytical queries on massive data sets. When you organize by columns, the system can read only the data from the columns that are actually relevant to your query, which can speed things up tremendously.
So think about analyzing website traffic data. You might have millions of rows representing individual visits to a website, but if you're only interested in analyzing, say, the referring domain and the time of day for each visit, a column store can quickly pull that specific data without having to process the entire data set.
Exactly. And lastly, Dataiku talks about graph databases, which use a network-like structure to represent entities as nodes and the relationships between those entities as edges.
And those are really powerful for uncovering patterns and connections within data, right?
Absolutely. Dataiku gives some great examples of where graph databases shine, things like fraud detection, social network analysis, recommendation engines, anything where understanding the relationships between things is crucial.
And before we move on, let's not forget about good old file systems, which Dataiku reminds us are still a very common way to store all sorts of files.
Right, from simple text files and spreadsheets to images, videos, audio files, all kinds of stuff.
And it's interesting how Dataiku and AWS both made the point that many of these storage systems aren't just passive containers for data, they can also act as computation engines.
Meaning you can actually process and analyze data right where it lives without having to move it around, which can be a big performance boost.
Makes sense. So we've covered databases and file systems, but there are a couple more storage-related components that AWS really emphasizes: data lakes and data warehouses.
Right, so data lakes, AWS describes them as these massive centralized repositories that are designed to hold vast amounts of raw data.
And by raw data, you mean?
I mean, data in its original format, exactly as it was collected, without any transformations or cleaning or formatting.
So it's kind of like a huge data dump.
In a way, yeah. But AWS emphasizes that this raw data is actually incredibly valuable for certain types of analysis. It allows you to preserve the full fidelity of the data, which can be important for things like auditing, data exploration, or building machine learning models that require the raw, unprocessed data as input.
Makes sense. And this raw data lake approach can also help break down data silos, which are those situations where data is trapped within different departments or systems that don't communicate well with each other.
Exactly. By having the central lake where all the raw data lands, it becomes easier to create a unified view of the data across the entire organization, even if it came from different sources and in different formats.
Now, data warehouses, which IBM, AWS, and Dataversity all talk about, they're also centralized repositories, but they serve a different purpose.
Right. While data lakes are all about storing raw data, data warehouses are focused on storing data that has been processed, cleaned, and structured in a way that makes it ready for analysis.
So it's more like a carefully curated library of data ready to be used for things like business intelligence, reporting, and data science.
Exactly. And the data in a data warehouse, it typically goes through an ETL process, extract, transform, load, to get it into that nice, clean, usable format.
So imagine you have customer data in one system, sales data in another, and marketing data in yet another, and none of these systems are talking to each other.
Right. Classic data silo situation.
The ETL process would extract the relevant data from each of those systems, transform it so it's all in a consistent format and can be combined, and then load it into the data warehouse where it can be analyzed holistically.
It's about bringing order to the chaos.
Absolutely. And then building on the idea of data warehouses, we have data marts, which IBM and Atlan both explain are basically smaller, more focused subsets of data warehouses.
Right. These are designed to serve the specific needs of particular teams or departments within an organization.
So, for example, the marketing team might have its own data mart that contains only the data relevant to their marketing campaigns, while the sales team might have a different data mart that's focused on sales performance metrics.
And Atlan highlights that this approach makes it easier and faster for teams to get the specific insights they need without having to wade through the entire data warehouse.
Okay, so we've got all this data coming from various sources. We've got different storage solutions for different types of data. And we've got these central repositories, data lakes, and data warehouses where it all comes together.
But none of this works if the data is trapped in silos or if it's impossible to combine data from different sources in a meaningful way.
Right. That's where data integration comes in. At LAN and AWS, they both really emphasize the crucial role of data integration in ensuring that all this data from disparate sources can actually be accessed and analyzed as a cohesive whole.
It's about breaking down those walls between different systems and making sure the data can flow freely.
Exactly. And IBM also highlights that effective data integration is a key weapon in the fight against data silos, which we've talked about a few times already.
Right. Those silos are the enemy of a well-functioning data-driven organization.
Totally. Now, another huge piece of the puzzle is data quality, which Atlan and IBM both stress is absolutely fundamental.
I mean, it makes sense, right? If the data itself is inaccurate or inconsistent, then any analysis you do, any decisions you make based on that data, they're going to be flawed.
Garbage in, garbage out, right?
Exactly. And Dataversity, they really drive this point home by talking about the importance of a data quality DQ mindset.
Mm.
It's not just about having the right tools and processes. It's about creating a culture within the organization where everyone understands the importance of accurate and reliable data.
So it's about building quality into every step of the data journey, from collection to storage to analysis. And of course, we can't talk about data without talking about data governance.
Absolutely essential.
AWS, Dataversity, and IBM, they all point out that data governance is all about establishing the rules of the road for how data is used within an organization.
Right. It's about defining roles and responsibilities, establishing standards for data quality, ensuring data security and privacy, and making sure everyone is on the same page when it comes to using data responsibly and ethically.
AWS also specifically mentions the importance of auditing and tracking data usage to ensure compliance with regulations, which is a huge consideration these days.
Oh, for sure. And Dataversity adds that data governance is often a collaborative effort, involving people from different teams and departments working together to define and enforce data policies.
Now, one aspect that I think often gets overlooked, but that both AWS and Atlan point to as absolutely critical, is metadata management.
Metadata, right? It's data about data.
Exactly. Think about a library. You've got all these books, but you also need a catalog that tells you what each book is about, who wrote it, when it was published, where to find it on the shelves. Metadata is like that catalog for your data.
It provides context, helps you understand what the data means, how it was collected, how it relates to other data, all that good stuff.
And Dataversity really emphasizes how crucial this is for distinguishing between different data entities, making sure you're using the right data for the right purpose.
And IBM points out that in an ideal world, metadata is active. That means it's not just static information, it's constantly being updated, giving you a real-time view of the data and how it's being used.
So we've covered data sources, storage, integration, quality governance, and metadata. But the ultimate goal of all this careful data management is to actually extract valuable insights and make better decisions.
Right. That's where data analytics comes in.
And AWS talks about different approaches to data analytics, from traditional data warehouses and batch reporting, which are still important, to the growing field of streaming analytics, which is all about getting insights from data in real time.
Think about monitoring social media trends, tracking website traffic, or even detecting fraudulent transactions as they happen. That's the power of real-time analytics.
And then there's a really exciting world of AI and machine learning, which AWS highlights as being crucial for building intelligent applications and making predictions about the future.
And both of these rely heavily on having access to high-quality, well-organized data, which is exactly what a well-designed data architecture provides.
Okay, so we've got all these individual pieces, the sources, the storage, the processing, the governance, the whole shebang. But how does this actually all get implemented in the real world?
AWS gives us a really useful mental model for this. They call it a layered approach, and it involves breaking down the data architecture into distinct layers that group together different processes and technologies based on their specific objectives.
So it's a way to organize all the moving parts.
Exactly. And the first layer they describe as the staging layer, which is basically the entry point for all that raw data that we talked about earlier, regardless of whether it's structured, semi-structured, or unstructured.
So it's the initial landing zone.
Right. And AWS stresses that this staging layer should be designed to be flexible. If you impose rigid data formats and structures too early on, you might accidentally limit how that data can be used down the line.
It's kind of like trying to fit square pegs into round holes.
Exactly. But at the same time, as AWS points out, you can't just have complete chaos in this staging layer. You still need some level of consistency. If the same piece of information, like a customer's phone number, is formatted differently depending on where it came from, it can cause all sorts of problems later on.
Right, so it's a balancing act between flexibility and standardization.
And to help manage this balance, AWS actually suggests breaking down the staging layer into two sublayers. First, you have the raw layer, which is kind of like the data's pristine state, untouched and unaltered.
So it's stored exactly as it was collected, no matter how messy or inconsistent it might be.
Precisely. AWS emphasizes that this raw layer is really valuable for auditing purposes, data exploration, and for building machine learning models that often benefit from having access to the original unprocessed data.
Kind of like preserving the original negative of a photograph.
Exactly. And then you have the standardized layer, which is where that raw data undergoes some initial processing and cleaning to bring it up to a minimum level of quality and consistency.
So this is where you might fix formatting errors, remove duplicates, and apply some basic validation rules to make sure the data is at least usable.
Right. And AWS points out that the standardized layer is super important for enabling self-service business intelligence and basic analytics.
So people can start exploring the data and getting insights without having to deal with all the raw messiness.
Exactly. Now, once the data has gone through those initial stages, it typically moves into the conformed layer.
Okay, so what's special about this conformed layer?
Well, this is the point where data from all those different source systems is brought together and integrated to create a single, unified view of the data. AWS explains that the goal is to develop an enterprise data model, which is basically a shared understanding of key business entities, things like customers, products, orders across the entire organization.
So you might have customer data coming from the sales system, the marketing system, the customer support system, all with slightly different pieces of information and potentially different formats. The conformed layer is where all of that gets reconciled and combined.
Exactly. And AWS points out that having this unified, conformed view of the data is really important for accurate reporting and analysis, for ensuring compliance with regulations, and for just generally making sure that everyone in the organization is working with the same consistent data.
So it's about eliminating those inconsistencies and discrepancies that can creep in when data is scattered across different systems.
Precisely. And finally, we have the enriched layer.
Enriched, huh? What does that mean?
AWS describes this as the layer where the conformed data is further transformed and enriched to create what they call data products.
Data products. Okay, so these are
These are basically data sets or data structures that are tailored to meet the specific requirements of a particular use case or application. This could be anything from building dashboards that provide real-time insights to generating detailed customer profiles that are used for personalized marketing or recommendations.
So it's taking that clean, consistent data from the conformed layer and then shaping it into something that's ready to be used for a specific purpose.
Exactly. And AWS emphasizes that these data products are typically cataloged within the architecture so that people can easily find and access the data they need.
So it's kind of like a library of prepackaged data insights.
Exactly. And that's the layered approach, from raw data in the staging layer all the way to enriched data products ready for action. It provides a really useful way to think about how data flows and transforms within an organization's architecture.
It's a great way to visualize the journey of data from its rawest form to its most refined and usable state. Now, we've talked about these layers, but there are also different ways to structure an entire data architecture, aren't there?
Right, different architectural styles. And AWS and Dataversity both highlight two fundamental types: centralized and distributed.
Okay, so what's the difference?
Well, it all comes down to how that conformed layer we just talked about is managed. In a centralized architecture, AWS explains that the conformed layer is really the heart of the system. It's all about creating and managing common business entities, things like customer or product, that are intended to be used universally across the entire organization.
So it's like having one central authoritative source of truth for all the core business data.
Exactly. And AWS emphasizes that this centralized approach is great for data governance, especially when it comes to sensitive information. It's also really good for managing metadata because you have a single place where all that data about data is stored.
But it sounds like there could also be a downside to this centralized approach. What if different teams or departments have slightly different needs or want to use the data in different ways?
That's where the distributed architecture comes in. In this approach, each domain or business unit essentially manages its own conformed layer.
So instead of having one central definition of customer that everyone has to use, the marketing team might have its own customer definition that includes specific attributes relevant to their work, while the sales team has a different definition.
Exactly. AWS points out that this distributed approach provides a lot more flexibility and autonomy for individual teams, but it also introduces some challenges when it comes to data discoverability and governance.
Right, because now you have all these different definitions floating around.
Exactly. So both AWS and Dataversity emphasize that a central metadata catalog becomes even more crucial in a distributed architecture. It acts as a directory that helps people find the right data assets, understand their lineage and quality, and track how data is flowing between different parts of the organization.
So it's kind of like a map to navigate the decentralized data landscape.
Exactly. And Dataversity also mentions some specific technologies and patterns that are often used to enable this type of distributed architecture, things like data mesh, data fabric, and data lakehouses.
Okay, so it sounds like there's no one-size-fits-all answer when it comes to choosing between centralized and distributed architectures. It really depends on the organization's specific needs and priorities.
Exactly. And Dataversity also touches on a whole bunch of other types of data architectures like monolithic, microservices, cloud-based, hybrid, event-driven, and more. It just shows you how diverse the world of data architecture can be.
So we've talked about the layers of a data architecture and the different ways it can be structured. Now let's dive into some of the key considerations that Dataiku highlighted in their crash course: storage, security, and computation.
And Dataiku kicks things off by reminding us that we have a whole buffet of storage options to choose from: databases, data lakes, file systems, all that good stuff.
But the key, as they put it, is choosing the right storage for the expected operations. What do they mean by that?
Well, it means thinking carefully about the type of data you have, how much of it you have, how often it needs to be accessed, and what kind of processing you need to do on it.
So if you have a lot of data that changes very frequently, like real-time stock prices, you'd probably want a different storage solution than if you have a large archive of historical documents that are rarely accessed.
Exactly. It's about matching the technology to the specific needs of the data and the business.
Makes sense. Now, security, obviously a huge concern for anyone who handles data. Dataiku used a clever analogy to illustrate some key security principles. The airport analogy. Can you walk us through that?
Sure. So Dataiku breaks down data security into three essential levels, and they compare them to the different stages of airport security. First, you have authentication, which is like showing your passport or ID at the airport check-in. It's about proving who you are to the system.
So it's verifying your identity.
Exactly. Then you have authorization, which is like having your boarding pass.
Mhm.
It tells the system what you are allowed to do once you've been authenticated.
So you might be authorized to access certain data or to perform certain actions within the system.
Right. And lastly, you have auditability, which is like having your seat assignment and the flight records. It means there's a log of who accessed what data, when, and what they did with it.
So you have accountability and traceability in case something goes wrong.
Exactly. And Dataiku also talks about different levels of permissions within a data system. Who has read access, who has write access, who can execute certain programs. They really emphasize the principle of least privilege, which means granting users only the minimum level of access they need to do their job.
Which makes sense. It minimizes the potential for mistakes or malicious activity.
Exactly. And Dataiku ties all of this back to regulatory compliance, things like GDPR, which are all about controlling access to data and protecting people's privacy.
Okay, so we've covered storage and security. Now let's talk about computation. Daitaiku's explanation focuses on what happens when you have so much data or you need to do such complex processing that your existing computing resources just can't keep up.
Right, so you need to scale up your computational power somehow. And Dataiku describes two main approaches: vertical scaling and horizontal scaling.
So what's the difference?
Well, vertical scaling is basically like taking your existing computer and making it more powerful. You might add more memory, upgrade the processor, get a faster hard drive. It's like adding more floors to an existing building. Horizontal scaling, on the other hand, is about adding more computers to the mix, creating a cluster of machines that can work together to handle the workload. That's more like building a campus of multiple buildings instead of one giant skyscraper.
And Dataiku points out that neither approach is inherently better. It really depends on your specific needs and budget.
Right. Vertical scaling can be easier to manage in some ways, but there are limits to how much you can scale a single machine. Horizontal scaling gives you more flexibility and potentially more power, but it also introduces more complexity in terms of managing the distributed system.
Makes sense. And Dataiku also talked about the cloud, which is obviously a huge topic these days. They define cloud computing as essentially using a network of remote servers hosted and managed by someone else to store, manage, and process your data rather than relying on your own physical servers.
They use a great analogy to illustrate this. They compare it to planning a family trip. Driving your own car is like managing your own IT infrastructure on premises. Renting a car is like using infrastructure as a service, IaaS, in the cloud, where you rent the basic building blocks like virtual servers and storage. And hiring an Uber or a private car service is like using managed services, where the cloud provider not only gives you the resources but also takes care of the day-to-day management for you.
That's a really clear way to understand the different cloud models. And they specifically mentioned the big three cloud providers, AWS, GCP, and Azure, which offer a huge range of services.
Right. And when it comes to data architecture, Dataiku highlighted some of the key benefits of using Agilus in the cloud, like the ability to scale your resources up or down as needed, the increased resilience and fault tolerance of cloud infrastructure, and the fact that you typically only pay for what you use.
But they also cautioned that those pay-as-you-go costs can add up if you're not careful, so it's important to have a good handle on your cloud spending.
Definitely.
Okay, so we've explored storage, security, and computation in quite a bit of detail. Now let's zoom out and consider why having a well-designed data architecture is so important for an organization as a whole. Our sources mentioned a bunch of benefits.
Yeah, SAP, IBM, Atlan, and Dataversity, they all contribute to this really compelling list of reasons why data architecture matters.
Let's hear it.
Okay, so IBM, they start off by emphasizing that good data architecture reduces data redundancy and improves data quality. And Atlan echoes those points, also highlighting the improved data integration capabilities that come with a solid architecture.
Which makes sense. If your data is well organized and managed, it's going to be more accurate and consistent, and it's going to be easier to combine data from different sources.
Exactly. And both SAP and Atlan emphasize that good data architecture makes data more accessible and reliable.
Meaning it's easier for authorized users to find and use the data they need, and they can trust that the data is accurate and up to date.
Right. And scalability is another key benefit that both SAP and Atlan mention. A well-designed architecture can handle growing data volumes and increasingly complex processing demands without falling apart.
So you're not constantly running into roadblocks as your data needs grow.
Exactly. Security is also a big one, obviously. A strong data architecture helps protect sensitive information and ensures compliance with all those regulations we talked about earlier.
Right, because data breaches are a nightmare.
For sure. And SAP also points out that good data architecture increases organizational agility. It helps businesses adapt more quickly to change because they have a solid data foundation to build on.
That's a huge competitive advantage in today's fast-paced world.
Totally. And then IBM adds that good data architecture supports the entire data lifecycle management process, from the moment data is created to when it's archived or deleted.
So it's not just about storing and analyzing data, it's about managing the entire data journey.
Right. And Dataversity chimes in with some more business-focused benefits. They talk about how a well-designed data architecture helps align IT systems with business goals, manages complex data environments, provides insights into new business opportunities, and even helps organizations prepare for future challenges.
It really paints a picture of data architecture as a strategic enabler, not just a technical necessity.
Absolutely.
So, considering all these benefits, how should an organization actually approach building or improving its data architecture? Atlan and Dataversity offer some really valuable insights into strategies and principles.
Hey, thanks again for checking out this week's episode of the Data Radio Show. If you haven't already, hit that like button, share the video, or subscribe to the channel. And as I mentioned at the beginning of the episode, if you're keen to go to this event that we've got, the meetup that we've got in Melbourne on April 3rd, there is a link in the description down below for you to be able to RSVP. Super easy, check it out, learn a little bit more from our friends over in Scale Free who have come over from Germany to Australia for the event. It's bound to be absolutely fantastic and incredibly informative. Until next time, look after yourself, live long, prosper, be one with the Force, and I will catch you all next time.